Welcome, this is the Unit 3 review. Hopefully you've worked through every single problem, and this is just your checking your work. If you are struggling on a certain problem, try to work it out as much as possible before referring to this. All right, let's get started. So 3a is find the inverse of a function. To find an inverse, algebraically, you switch x and y. So the f of x was y, let's make that x. The x here, let's make it y. And first thing we need to do, we need to solve. We need to get y by itself. In this case, first thing we need to do is subtract 3. X minus 3 equals 1 over y minus 2. Now usually if you're trying to get y by itself, you're not moving it, you're moving everything away from it. Well, in this case, you're dividing by y minus 2. The only thing you can do, because we have it divided by, is multiply. So you multiply by y minus 2. Multiply both sides by y minus 2. Okay, when you do that, this cancels, and let's move this over here. Go over. I have y minus 2 times x minus 3 equals 1. Now, since the y is out of the denominator, we can concentrate on moving every term and expression away from it, from y. So in between both parentheses is a multiplication. Easiest if we just divide by x minus 3 here. That moves x minus 3, and then we have y minus 2 equals 1 over x minus 3. We're going to add 2, and the problem started out f of x, so we should do inverse of f of x equals 1 over x minus 3 plus 2. The 2 and the 3 don't go together. You have divided by x minus 3. The x minus 3 is together. The 2 is on the outside. So there's the answer for number 1. Moving on to number 2. Number 2, we have f of x equals 3x plus 5. So the f of x, remember that's y, and we have an x. So let's change them. Let's switch them. X, y. Now let's get y by itself. This one's a little easier. So you subtract 5, x minus 5 equals 3y, and divide by 3. And instead of y, we start out with f of x, so we should have f negative 1x equals x minus 5 divided by 3. So remember, we're doing these by reverse order of operations. Moving on to number 3. So switch your x and y. X, y, reverse order of operations. If I'm looking on the right side, we have a subtract 2 inside parentheses, we have a square, and we have a plus 3. The last thing you would do is add 3 if you're doing order of operations. So that's the first thing we should take care of, subtract 3. So it becomes x minus 3 equals in parentheses y minus 2 squared. And then the next thing to uncover the y operations-wise would be to take care of the square, which is the opposite is the square root. Square and square root. So we have the square root of x minus 3 equals y minus 2. Let's add 2. Add 2. And I'm actually going to take the y and move it over to the other side just to make it look a little nicer, because usually we start out y or f of x. So we have inverse of f of x equals x minus 3 plus 2. Number 4, very similar to number 3. Switch our x's and y's. We look on the right side. What is our? If I had a number in for y, how would I simplify this? I'd subtract 2 first, then I'd cube root it, and then I would add 5. I need to do the reverse order of this to simplify. So instead of add 5, we subtract 5. X minus 5 equals cube root x minus 2. Opposite of the cube root, cube. So I have the x minus 5 cubed equals, switch to y. Y minus 2, because the cube and cube root cancel. Now let's add 2. So add 2 to this side. So again, I'm going to move, y was on the right side of the equal sign, let's move it to the left. So it's inverse of f of x equals x minus 5, or quantity of x minus 5 cubed plus 2. Graphing. There are multiple ways you can graph the inverse. We can graph the inverse by using your calculator. So we can put this into the calculator. So I put it in the calculator, y equals, and then remember a cube root is under the math key. Number 4 is cube root. And we'll put this in, close out the parentheses. Different calculators have different methods of doing this, but virtually it's the same thing. Sometimes you have to go to zoom 6 to reset the window. Let's look at the graph. You got to get some points off this graph. To get the points, you go to second graph. And we got to pull off some points here. You can page up or down to get different points. I'll just search for 3 points. So, put back on the calculator. We have -1, -3, 0, -2, and 1, -1. Let's plot those points. -1, -3, 0, -2, 1, -1. Now this is a cube root function. Cube root function looks like this. Now we do have to graph the inverse. Inverse is, so the inverse of this, g of -1, to graph that, we'll just switch x and y. So it was -1, -3, it becomes -3, -1. It was 0, -2, it becomes -2, 0. And it was 1, -1, it becomes -1, 1. Let's plot these points. -3, -1. -2, 0. -1, 1. Now these 3 points are orientated in the same manner as these 3 here. So we got to be careful. What is the inverse? So we need to think, what is the inverse of the original function? The original function is cube root, so we know the inverse is cubic. Cubic shape is tall from unit 1. So this is our answer. This is the inverse. You want to label it. G of -1 means it's inverse. You want to do dashed lines and solid lines. Solid lines are the inverse. That's fine. Moving on to number 6. Actually, we could talk about number 5 a little bit more. Number 5, another way to do this problem is just work it out like we did for 3a. So you're going to switch x and y. Solve for y. X plus 2 equals the cube root of y. Cube it. And graph this. X plus 2 cubed. That's going to be our inverse. If you put that in the calculator, so we're going to put x plus 2. So this is another way to solve the same problem on number 5. If you understood the other way, keep doing it. So x plus 2 cubed, if we graph this, it should look just like my red line there. That's pretty close. Let's look at some points. Yeah, -3, -1, check. -2, 0, and -1, 1. Check, check. Those are my 3 points. Perfect. Alright, let's move on to number 6. I'm just going to do this with, put it in the calculator, switch to x and y, and we need to talk a little bit about what's the inverse of a linear function. So put it in the calculator. 2x plus 5. Remember, you can solve this like we did for 3a. Just solve it algebraically. Graph this. Let's get some points off of the table. There are many points. Let's just find points that actually fit. So -3, -1, -2, 1, -1, 3. -2, -2, 1. -1, -3. 3. Plot those points, -3, -1, -2, 1, and -1, 3. Alright. Not the inverse, so let's put it as a dashed line. Inverse of this, switch x and y. So the inverse, I'll just show that with the inverse of g of x. Switch x and y. Get -1, -3, 1, -2, and 3, -1. Plot those points, -1, -3, -1 or 1, -2, 3, -1. And inverse of a linear function is a linear function. Graph this. If you wanted to switch the x and y, so do this like 3a, you're going to take the g of x becomes x, and the x becomes y. So if you didn't believe me that the inverse is of a linear function is linear, solve it. It's fine, don't believe me, just solve it. Divide by 2. And if you were to graph y equals, in parentheses, x minus 5, divided by 2, put that in the calculator, you're going to get this red line. Alright, moving on. Alright, we have for C, find the composition of two functions. A couple different types of compositions here. We have number 7 is g of h of 3. Some of you would rather see this g of h of 3. So we have, if you want to rewrite it, it's g of h of 3. Some people actually put parentheses just right here because they don't like this little of symbol. So let's, what we're doing here, there's a couple different ways people solve these. I think the easiest way is to start from right to left. So I'm looking at the 3, and it's going to be, first I'm looking at the h of 3. So I look at h of x, and the h of x, well, instead of x, it's got 3 there. So h of 3 equals, and I'm going to substitute 3 in for the x in the h of x. So this, where x is, becomes negative or positive 3. Let's simplify that. So the left side is just notation. Simplifying -3 plus 3 is 0. Well, that's what h of 3 equals is 0. So I'm going to rewrite this here as g of h of 3 is 0, so it's going to be g of 0. So g of 0, and what does that mean? Well, when we look at g of x is now 0, so it's -4 times 0. So, in all, after it's all said and done, g of h of 3, -4 times 0 is 0, so g of h of 3 is 0. We're not number 8. Number 8, we're not as fortunate, we don't have a number, so we have x is going to go into the g function, so it's g of x first. I already have g of x, and x is going to go into the g, it's already x, so we don't do anything with that. We need to take that, and we need to, so it's going to be g, and what the g of x equals is 3x minus 7. We need to, instead of, typically this is g of x, now it's g of 3x minus 7. So what we have to do is we need to substitute. Well, there's only one equation up here. So what I do is I just put another equation up here. So then it looks the same as the other problems. So I need to take where the x is here, the x, I need to put 3x minus 7. So we have 3 up here, and where the x is, where this x is, I'm going to put 3x minus 7. And subtract 7. And let's simplify this. So distribute, so we get 9x, 3x, 3 times 7 is 21, minus 7, 9x minus 28. And that is what g of x equals. Next, we have h of g of x. So, here's g of x, what does that equal? Well, it equals 2x minus 3. So let's rewrite this. We have h of 2x minus 3. And it was h of x, now it's 2x minus 3. So where the x is in h of x, you have to replace it with 2x minus 3. And remember this negative here, it's like a negative 1. You need to distribute first. So equals negative 2x plus 3 plus 7. Simplify that down a little further. We have like terms, 3 and 7, 10. So h of g of x equals negative 2x plus 10. Next, a little different notation. It means the same thing. This is f of g of x. The g of x goes into g, it's already there. So then we replace the g of x with what it equals, 3x plus 2. And so we have f of 3x plus 2. So it was x. So where these x's are, we need to replace it with 3x plus 2. So x squared, so we replace when I substitute. I'm actually going to put it in parentheses, I always do. So parentheses 3x plus 2 squared plus 4 times 3x plus 2. Alright. This square means times itself. So we need to rewrite this. 3x plus 2 squared means 3x plus 2 times 3x plus 2. And then we can multiply this 4 in if you like. So 4 times 3x is 12x, 4 times 2 is 8. And let's multiply this all out. So we have, right now I'm looking at this portion here. Binomial times a binomial. 2 terms times 2 terms. Some of you know it as FOIL, some of you know it as double distribution. Multiply everything times everything. We have 3x times 3x is 9x squared. 3x times 2 is 6x. 2 times 3x is 6x. 2 times 2 is 4. Close. And now let's bring this 12x down. Plus 8. Get our like terms together. Oh, that's a lot of stuff. There's a 9x squared. 6x plus 6x plus 12x is 24x. And 4 plus 8 is 12. So all this craziness, f of g of x equals 9x squared plus 24x plus 12. Alright, last thing, we have, well it says 2g in here, I don't know why. That's supposed to be 3D. This is not a three-dimensional problem. Just kidding, that was a terrible joke. We have to use compositions. You have to use compositions to verify that these two functions are inverses. Have to use compositions. So you're supposed to go h of f of x equals x and f of h of x equals x. So you're supposed to prove h of f of x, you simplify it down, becomes x, and that f of h of x equals x. Well, you're supposed to do both. I'm just going to ask you to choose one. Choose one of these. So just because it's on the bottom here, let's choose f of h of x. So in this case, I have to see that it's going to equal x. Well, let's do this. We have h of x, what it equals. It's the cube root of x minus 1. I'm subtracting 2. So inside I'm going to take, so instead of h of x, I'm going to put the cube root x minus 1, subtract 2. Now let's put that into the f of x. So instead of x, we have the cube root of all that. So we have 1 plus, in parentheses, now where the x is, I'm going to put the cube root x minus 1, subtract 2, and then plus 2 from here, cubed. Now you need to simplify these in the correct order. I don't actually need the parentheses around what I substituted in. The only reason why you need parentheses is if you're multiplying or to a power. In this case, I don't need them. So if I don't need them, you can drop them. And the first thing you're going to simplify out is you have to subtract 2 and add 2. So I'm just going to rewrite this right side. We have 1 plus cube root of x minus 1. So the minus 2 plus 2 is canceled out. Cube root. And now it's cubed. Okay, so next thing on our list, we have cube root and cube. Those are the next things that we cancel out. And we're left with 1 plus, and the parentheses get dropped out because we no longer have a cube, x minus 1. 1 plus x minus 1, well, those will, 1 and negative 1 will cancel. And we're left with x. Yay! We're left with x. So they are inverses. If you're not left with x, they're not inverses, but 3D, you're proving that they are. You're verifying they are, so they will be inverses. So you have to end up with x. Come tomorrow. I'll be after school on Wednesday. Come tomorrow with any questions. All right. Thank you. Have a good night.